This video is going to go over the particles that make up an atom and various numerical quantities we can get with that information. So the first thing we're going to talk about are the different particles. We've got our protons, our neutrons, and our electrons. The protons and neutrons have a lot in common in terms of their size and where they are found in the nucleus. They are both where they are found in the atom. They are both found in the nucleus. And they have comparable masses, as you can see in the picture at the bottom. You can also tell that they have differences in terms of their charges. The protons are positively charged while neutrons do not have a charge. They are considered electrically neutral. Protons help us determine what element we have. Every element on the periodic table has a unique atomic number, which is its number of protons. While neutrons help us determine what form we are finding our element in, aka what type of isotope we have. The more neutrons that are present, the greater our isotope number is, and that's represented with a mass number. Our electrons they still fit into the picture. They're actually really important in terms of forming compounds, but they are not found in the nucleus. They are outside in general regions called orbitals. They are negatively charged and they are very, very tiny, and they distinguish between atoms and ions of respective elements. We'll talk about those terms a little bit more on the next slide. Atoms are electrically neutral, so the protons and electrons, the positive protons and negatively charged electrons are the same, whereas with an ion we have an unequal number of electrons compared to protons. When you have more protons, you are positively charged and you are considered a cation. When you have more electrons, you are negatively charged and you are considered an anion. The pictures to the left show neutral atoms with equal numbers of protons and electrons, and then what happens as sodium loses an electron to form a +1 ion, while chlorine gains that electron to make a -1 ion. Isotopes is a different term from those two. You can have an isotope that's an atom, and you can have an isotope that's an ion. But isotopes kind of beat to their own drum because they don't have anything to do with the electrons. You will only have isotopes for the same element as in the picture to the right below the table. So you see two isotopes of carbon, so they have the same number of protons, the same number of blue positive circles, but they have a different number of purple circles representing the neutrons. In carbon-12 we have 6 protons, and that 12 is my mass number, and so the difference between that gives me my neutrons, 6 as well. Whereas carbon-14 still has 6 protons, but to get up to 14 for its mass number it has to have 8 neutrons. So we've talked about atomic number, mass number, and we're also going to talk about charge, and that's going to be shown in our next slide. And that is representing an element symbol. The A part, the number found in the top left-hand corner, gives us our protons and our neutrons. The Z term in the bottom left-hand corner gives us just our protons. And the C term in the top right-hand corner will be present if we have an ion, and it's the difference between our positively charged protons and our negatively charged electrons. And you can see that in the two pictures to the right. They're both magnesium, so they have the same bottom left number. They have the same number of protons, the atomic number. These are isotopes of each other because they have different numbers of neutrons, which are represented by the different mass numbers. And the symbol on the left is an atom. It has the same number of protons as electrons, which is why there is no number recorded in the top right corner. While the one to the right is a charged ion. It's a cation with a charge of +2. Indicating that it has 2 more positive protons than it does negative electrons. So we're going to do a little bit of practice with these. First one we're going to look at is how many protons and electrons are in an oxygen atom. The words oxygen and atom are going to be the most helpful. If we look on our periodic table, we're going to find the symbol O, and there will be a number between O and oxygen, and that is representing how many protons, it's this atomic number, are present in oxygen. So anytime you know the element name, you can find on your periodic table how many protons it has. Because this is an atom, we know that the protons need to cancel out with the electrons. They need to be equal. So if I have 8 protons, I must have 8 electrons. In our second example, we're finding protons and electrons again, but this is with a barium ion with a charge of +2. The 56 represents again our atomic number, which will be our number of protons. Because we are a +2 ion, we have 2 more positive protons than we do electrons, so therefore our electron number has to go down by 2 to 54. In an isotope name, you will see the name of the element, a dash, and then you will see a number coming after it, and that number is representing its mass number. I cannot ask you to find neutrons without giving you that information, just like I can't ask you to find the number of electrons in an ion without telling you its charge. Silicon, if we look on our periodic table, has 14 protons. To get the neutrons, I would take the difference between that mass number, which is my protons plus neutrons, and the 14 protons I just came up with. So 28 minus 14 would give me 14 neutrons. In our next set of examples, we're going to be making some symbols or analyzing some symbols. In the first one, we want to find out what element we have when we have 34 protons. So we would go look on our periodic table and find out that that is selenium. And because we know that the protons and electrons are not equal, we can also find the charge of this element. In this particular ion, because it has 2 more electrons, would have a charge of -2. In our last two, they're kind of going to be mirror images of one another. In the first one, you're given a symbol with the information for atomic number, mass number, and charge, and you're asked to find the protons, the neutrons, and the electrons. Our bottom left-hand number gives us our protons. Our top left-hand number gives us our protons plus neutrons. So if we subtract the atomic number away from the mass number, we will get the neutrons by themselves, and that gives us 61 neutrons. Because our charge is positive, we have 1 more proton, so if we started with 47 protons, we would go down to 46 electrons. The electrons can change for an ion as it switches from an atom to an ion, but the protons can't because that makes us have a new element. In our last example, we have that we're writing a chemical symbol with 52 protons, 76 neutrons, and 54 electrons. The protons tells us what element we have, which would be Te for tellurium, and the 52 would go in the bottom left-hand corner because that is our atomic number. The top left-hand number is our mass number, which would be the protons added to the neutrons, 52 plus 76, which would give me 128. This got cut off a little bit, but if you take a look at our electrons, we're going to see that our charge is a difference between those positive protons and negative electrons. And we have 2 more electrons, so we would take the difference and get a -2 charge. And this will be the last set of examples we do with atom structure. I will give you some pieces of information and you will have to fill in the remaining parts. So in the first row I told you that fluorine was an atom and it had 10 neutrons. You always want to start with your protons whenever possible, so if we go look on our periodic table, we will see that fluorine has 9 protons. And because it's an atom, we have equal numbers of protons and electrons, and so we will have 9 electrons as well. The charge for this will be neutral because we have equal numbers of protons and electrons. And so now we want to find our symbol and our isotope name. We can get our isotope name by adding the protons and neutrons together to get the mass number. Okay, sorry, I'm doing the symbol first. So fluorine will be our symbol. The atomic number will be in the bottom left-hand corner, which is a 9. The protons plus neutrons will be in the top left corner, which will be 19. And then we don't have a charge for this, so it would be neutral. And the isotope name would be fluorine dash the mass number, which would be 19. In our next example, we have oxygen as an ion. Oxygen has 8 protons if we go look for it on the periodic table. Because we're told it has a -2 charge, we have 2 more electrons, which means we would go from 8 to 10. O would go in the center, and the bottom left-hand corner would represent my number of protons, my atomic number, which would be 8. The top left-hand corner would be my protons plus neutrons, which would be 17, and my charge would be the -2. To name this isotope, I would write it as oxygen-17. In our third example, I've given you the electrons and the neutrons and the charge, and I want you to find the other pieces. Because I gave you the electrons and the charge, you can determine the protons. It would need to be one more, so that you would have a difference of +1. 37 tells us our element, which would be rubidium, and because it has a charge, it is an ion. Rb would go in the center, and then we would put the protons, our atomic number, in the bottom left-hand corner, 37. The top left-hand corner would be our protons plus neutrons, which would be 84. And our charge, which would be +1, would go in the top right-hand corner. As an isotope, this would be named rubidium-84. In our final example, I gave you silver 108. Silver tells us how many protons we have, and we have it as an atom because it has a neutral charge. The charge is 0. Because it's neutral, we also know its electrons, which would be 47 as well. And then to get the neutrons, I would take the difference between 108, my mass number, and my protons, and that would give me 61. So Ag would go in the center, 47 in the bottom left-hand corner, 47 plus 61, my mass number, 108 in the top left-hand corner, and I don't have to put anything in the top right-hand corner since this does not have a charge. And that would be the end of this video.